Researchers have created an autonomous drawing device that transfers metamaterials onto paper using pens and pencils, making 3 metamaterials that can be utilized to control the microwave portion of the electromagnetic spectrum served as their example of the new methodology. Metamaterials are synthetically created composite materials whose structured microstructures, rather than the material's chemical makeup, determine their properties. The structures can be utilized to alter electromagnetic waves in ways that aren't conceivable with ordinary materials because of their precise shape, geometry, size, orientation, and arrangement. According to Junming Zhao, the head of the research team from Nanjing University in China, metamaterials, especially those employed as absorbers, normally need to be thin, lightweight, wide, and strong. However, it is difficult to construct thin and lightweight devices using traditional substrates. Paper as the substrate can assist achieve these needs while also lending itself to mechanically reconfigurable or surface-conforming metasurface. The researchers explain their innovative method, which use mechanical pencils to create resistors and resistive coatings, and a ballpoint pen with conductive ink to create conductors, in the journal Optical Materials Express. They automated and improved this procedure by incorporating it into a computer-controlled drawing machine. Although inkjet printing technology has been used in the past to create paper-based metamaterials, Zhao claims that his sketching method is more flexible, easier, and less expensive. Our technique might be used to create metamaterial devices that absorb incident electromagnetic radiation from cell phones or other sources, as well as reconfigurable antennas and meta lenses. Robotic sketching. The innovative sketching device utilizes mechanical pencils with changing graphite contents or conductive ink containing pens. 3 stepper motors are used. 2 are used to move the pen or pencil in a horizontal plane, and the 3rd is used to lift or lower the writing instrument in a vertical plane. A computer regulates the drawing machine's characteristics, including movement speed. Zhao explained that some of the paper they tested did not work well with the pencils or conductive ink pens, which led to the sketch patterns having low conductivity. After some testing, we discovered that 0.22 mm thick paper, which is accessible and works well with conductive ink and pencils, provided the best results. The patterns that the researchers drew on paper with the conductive ink pen had a good conductivity of 3/106 Siemens per meter. In order to understand how drawing times, drawing pressures, and pencils with different amounts of graphite affected electrical resistance, researchers also investigated these variables. As a result, they were able to determine the prerequisites for creating patterns with a particular resistance. Making metamaterials from paper, the researchers created 3 distinct paper-based metamaterials: a polarization converter, an absorber, and a conformal coating meta surface using their novel sketching technique. They demonstrated that the polarization converter could rotate linear polarization by 90 degrees between 3.1 and 6.6 GHz with a conversion efficiency of over 90%. They created an absorber that weighed only 58.3 grams and had 90% absorptivity between 2.1 GHz and 10.5 GHz. The researchers also developed a conformal coating meta surface for radar cross-section reduction, which is a technique for concealing the radar signal in ships and aircraft utilized by the military. This meta surface contained 2 structural units that were 180 degrees apart in terms of reflection phase, allowing them to serve as the 0 and 1 elements for 1-bit coating. This meta surface, when twisted around a curved surface, reduced the radar cross-section by 10 dB for the frequency range of 8.94 to 11.59 GHz. We anticipate using drawing technology to create meta devices that might be worn or applied to the skin in the future to do many tasks, including electromagnetic shielding, Zhao said. We also intend to develop mechanically reconfigurable metamaterials that benefit from the flexibility of paper.